Okay, so let's get back to number 11. So since we can't think of any numbers that multiply to get 500, you know, 10 times 10 times 10 is 1,000, but nothing equally will add up to 500. Let's just go back and make a factor tree out of this guy here. 500 is, of course, 5 times 100, and of course 100 is 10 and 10 multiplied. And remember, we're looking for cubes, so we have 5 times 2, and we have another 5 times 2 here. So you can see that there in fact are 3 5s. So this factored out looks like 5 cubed times 4. Well, 4 can only turn into 2 squared, which that doesn't really help us much. So let's see what happens when we take out the 864. So we want to try to make this nice and clean. So let's first try to divide 864 by 4. So of course if you divide that, 864, you're going to get a 2, a 1, and a 6. So 216 times 4 is 864. And 216 turns out that is 36 times 6. And 36 times 6, of course, we can break that down. So now we have 6 times 6 times 6. So we have a perfect cube over here after we divided it by 4, right? So 864 turns out to be 6 cubed times 4. So with that in mind, we can go ahead and factor out a 4, and that leaves me with 6 cubed, or 216. And we already had x in cube factored, and plus we have 5 cubed. Okay, so now our a term turns out to be 2 terms, and our b term, to match up the formula, is just 5. So let's see if we can put it all together by using this portion right here. So we have 4, we're going to leave it outside. We're going to have a term here and a term here, and the formula says a plus b, so we have 6 cubed, excuse me, not 6 cubed, we have 6x plus our b term is 5, and then moving on to the second part of the formula, if a is 6x, and b is 5, so if you square a, you're going to get 36x squared. Since it's addition, the middle term of the quadratic is going to be subtraction, and a times b, 6x times 5 is 30x, and then b squared is just 25. So if you take the time to distribute these two terms and then multiply it by 4, you're going to come up with 864 cubed plus 500. Alright, so keep these two formulas in mind when you're solving these type of problems and you don't know how to factor them. Alright, let's take a look at number 13. This is just working with not really composite functions, but where you have two separate functions defined. Here's g, 4a plus 3, and h is this one. We're just going to perform operations on it. In this case, we're just going to add them together. So it's really just simple as putting g here, and then add h, which is a squared minus 2a plus 3. I'll just rearrange these two. And then this is the new formula. Might be, it doesn't say what it's defined as, but maybe they sometimes call this I or another letter like J. to create a new function. But anyway, let's see what we have in common. We have, no, those two aren't in common, are they? That's a 4a minus 2a. That leaves me with a positive 2a. We have a positive 3 and a positive 3, leaving me with 6. And then finally we have this a squared over here. So this is what the g plus h is equal to. Alright. Let's move on to number 15. 15, they just want us to find the inverse. And just to recall, if we had an easy problem like y equals 5x plus 3, to find the inverse of this function, all you simply do is switch the x and the y term, switch their values, switch the variables, I mean, and then you're going to solve for the new y. So the new y would equal, you have to subtract 3, and you get x minus 3 equals 5y. Then you divide that out by 5, and you would get that y is equal to x minus 3 divided by 5. And that's a pretty simple one, right? So let's take a look at this next problem, number 15. We're going to do the same strategy. So perhaps this letter is M, and this is N over here. So we're going to basically switch them. So we have the fifth root of m plus 1 divided by 2. Of course, the entire thing is inside the fifth root. So now we had the original problem was we replaced the g of n with m. So now we just need to solve for m again, and this will be our inverse. And the way we write this notation is we put a little negative 1 over here. So this is what it's going to equal once we solve for m. So how do you get rid of the fifth root? You multiply it by the fifth power. Okay? So if you multiply the fifth power by the fifth root, those two things cancel out, and you're left with m plus 1 divided by 2 equals n to the fifth. And solving for m, remember that's what we're trying to solve for, so we multiply both sides by 2, and we get 2n to the fifth. Of course that cancels, and you get m plus 1. So we're simply going to take 2n to the fifth minus 1 equals m. So to keep it back in the regular notation, since we kind of made a little substitution here, oops, we're going to just write this back here. So, good luck with that one. Number 17 and number 19 should be fairly straightforward. We'll just kind of review a few things on this one. Number 1 is when you're taking the square root, of course, let's understand that there's a second root, I suppose. So we're looking for numbers that can multiply by themselves to become the square root. So of course 10 times 10 is 100, so 10 gets to come outside of the square root, and we have x to the third, which means we have x times x times x. And since we're looking for just even pairs on this one, square roots, your x comes out, and that leaves that last x inside the square root. So hopefully that was a pretty easy problem. Alright, number 19. This is kind of like the imaginary problem that we had earlier. We don't want the square root to be on the bottom. And this one's fairly easy. I probably should have made this a little tougher, but let's just clean this one up. The square root of 9, of course, is 3, and square root of 25 is 5, so that one's just 3 over 10. Hopefully you didn't need any assistance on that one. Alright, let's go on to the next one. Problem 21, they just want you to write it in exponential form. So exponential form means that you don't want any radicals. So recall, excuse me, that if you have the square root of 25, you could always rewrite it in exponential form. If there's not a root up, if there's not a power up there, it's understood to be 25 to the first power. So that becomes a fraction, and whatever number's part of the radical becomes the denominator. So since it's square root, it's going to be 2. So these two things are equivalent. This is in radical form, and this is exponential form. So we're going to just apply the same principle to number 21. So we have x to the 7th power divided by the 6th power. Okay. All right. Number 23, we kind of use the same thought process. Here, when you have exponents, you can multiply the exponents to each term by distributing them in there. So we have 81 to the 1/2 power, and we have n. You multiply 1/2 times 2. Of course, this just leaves you with 2 over 2, or n to the first. And of course, just from the last problem, the square root of 81 is what that can be written as, which equals 9. So we just have 9n. Alright. Number 25 is just more properties of exponents. So you look for the bases and see what's in common. And of course y doesn't have any other y's in this problem. And the directions say these should only be positive. I'll cut that off, sorry about that. So of course this is not positive and that's not positive. But let's apply another property of exponents here. If you have the same base and the two numbers are being multiplied, we can add them together, right? So we have x to the negative 2 plus this 3rd power right here. And 3 doesn't have any other, there's no other numbers to multiply in this problem, so let's just put our whole number 3 out in front. And then we have, of course, y to the negative 4th by itself. And when we add these two together, of course, we get x to the first. So we have 3x. And then, of course, you'll remember that you take negative exponents and you push them down to the denominator, and you can make it positive. So that's that. Alright, 27, fairly straightforward problem. You have the square root right here on the right side. But, so you're thinking eventually, in order to get to x, you're going to have to square the equation. But right now, you don't have the square root just by itself. You have this plus 6. So let's push that 6 over to the other side by subtracting. And of course you get 10. And now you have the square root of the radical isolated by itself. So of course we're just going to take and square both sides. So squaring both sides, you get 100 equals 19x plus 5, and you just solve for x. So you get, subtract 5 and you get 95, and divide by both sides by 19 and you get what? 5. 5 equals x. Alright. Of course, you would go back and double check by plugging in your answer to the original equation just to make sure you didn't make a mistake. Alright. Okay, so 29 is kind of taking the last problem just a little bit tougher. So we're trying to solve for b, so of course we're going to subtract 10 and take away 10 from 522 and you get 512, and then you have b to the 3/2 power. Well, we're trying to get b by itself, so the easiest way to get rid of that is to multiply by the reciprocal exponentially. So when you multiply 2/3 times 3/2, of course you get 6/6, which reduces to b to the 1st power. Okay, so now you have a choice here. Let's break down this just to re-emphasize what we already talked about. If you have 512 and the exponent is a fraction, the denominator goes as part of the radical and then the square. And it doesn't matter what order you do this. If you want to square 512, you're going to get a big number. And if you take the cube root of it, it's a big number to be dealing with. So my point is you can take the cube root first. So let's just use a calculator to double check ourselves. So let's take the 512 and let's raise it to the 1/3 power. And that equals 8. Alright, so of course that means 8 times 8 times 8 equals 512. So if you know this fact, so what you have is 8, but you haven't squared it yet, right? So the answer to this is, of course, b is equal to 64. Now, of course, on a problem like this, we could have just gone right back and instead of putting it to the 1/3 power, we could have just put it to the 2/3 power right here, and we still would have got 64. Okay, so not too tough on those. All right, let's take a look at 31. Okay, 31. The big picture here is that we're taking the square root function, right? Because the x is inside the square root. So let's just recall, what does the square root of x as a parent function look like? Well, you know that anything inside the square root has to either be 0 or positive. 0 or a positive number. And so if you plug in the square root of 0, you get 0. So this graph starts off at the origin. And since if we put a negative number inside the square root, we get an imaginary point. So that's not on our real graph here. So the graph is going to live over here somewhere. Well, let's pick out a couple of points. Let's use x is equal to 1 and x is equal to 4. That should be enough. So if you have the square root of 1, that equals 1. And the square root of 4, that equals 2. So we just go over to our graph. This gives us the point 1, 1. And this gives us the point 4, 2. So our first point's there. 1, 2, 3, 4. Comes up. And of course this guy sort of bends over like this. Continues to increase. Alright. Well, the rest of this is just applying the basics of transforming graphs. And remember that when it's the x value, we think about the opposite, right? So we're going to shift the graph horizontally to the left 3 because negative 3 plus 3 is equal to 0, right? And this portion is the vertical shift. Since it's negative 3, it's going to go down 3. But this half here means that the height of the original curve, let's do it in blue, is going to be the 1/2 would mean that it just comes underneath there and it's going to reach half the value. So it's still increasing, but not quite as fast. So let's go ahead and find our original point. So we're going to go over to negative 3 and down 3. And that's our starting point. Right? So our domain of this graph is x is what? Greater than or equal to a negative 3. And what about our range? Our range starts off at what? Negative 3. It has to be greater than negative 3. So we could plug in a couple of points to see what happens. Yeah, let's do that. Well, if we have x plus 3, if we make this a 1, if we make x equal 1, what do we get? We get 4. And what is half of 4? 2. And 2 minus 3 is equal to negative 1. So when we're at x equals 1, we're actually still negative. So right about there. And, you know, we could do the same. We could pick 6 for x. But we're really just going to sketch the graph. So we know that the general shape is going to look like this. And it's eventually going to cross the x-axis. And do something like that. So anyway, that's generally the idea on that one. So let's go on to the next problem. Alright, the next problem, you know, you may not have, we didn't do conics much this year. In fact, we didn't do them at all. So I wanted you to be just familiar at least with the center. So let me just give you the formula for the circle. This is the formula for the circle. And it looks like this. X minus h squared plus y minus k squared equals to radius squared. So you notice that you're basically having to complete the square if it's not already given to you. And then the radius has to be in terms of square. So what this h and k are the x and y values of the center of the circle. So this gives us the center, and our radius is going to be however big this number r is. So in this problem, you can see our k, our y value, is already in subtraction form. So that means that k is a positive 4. But this one right here is not written properly, but now it is. So now the formula matches up. X subtract h. So h in this problem is a negative 4. So the center of the circle is over to the negative 4 and up 4. And we need to get our formula to match up. Luckily 9 is a perfect square, right? So we can rewrite it 3 squared. So now our formula would match up perfectly. It would look like this: x minus a negative 4 squared plus y minus 4 squared equals 3 squared. So we get negative 4 and 4 for the center, and we get the radius is equal to 3. So I'm not going to be able to draw a circle very well. Let's see if I can use the shape tool. How big is our radius? 3, right? So we're going to go up to 3, and that's going to be a point on the circle. We're going to go down 3. We're going to have a point there on the circle. We're going to go over 3. And so our circle is going to need to pass through here. I think when I copied this problem, I don't think this remained a square grid, so let's see how that does. It looks a little more square to me. So let me try that again. Let's just put our points back on there. We have negative 4 and 4. And we go up 3, over 3, a little more of a circle. Yeah, somewhat better. Alright, let's see if I can make this work. Let's see how that looks. Oops. I'm not having much luck, sorry. No, I'm about to give up. Oh, you get the idea. Alright, so circle's going to hit those outer blue points, but I'm not having much luck with this, so alright, let's move on. And number 34, we're going to try to, 35, we're going to make 35 try to fit into that same value, the same formula, where we have x minus h squared plus y minus k squared, and then we're going to try to write the radius, make it square. So you notice that we have to complete the square both for x and y. So this can be a bit of a tedious process. You just have to be careful and just do it step by step. So the first thing I'm going to do is I'm going to get the x's grouped together, and then I want to put the y's next to each other and move the number to the other side. So we start off by moving the positive 11 over and rewriting this thing. We get x squared minus 8x, and kind of group that up like that. And then we have positive y squared plus 4y equals negative 11. So we'll group these two things up. And we'll do the x in green. So you take half of a negative 8, and you get, of course, negative 4. You square it, and you get 16. So we know we have to add 16 over to the left side and the right side. And then we'll do the y in red. So to do the y, we have to take half of a positive 4, which equals positive 2. And then we're going to square that and get 4. So we're going to add 4 here and add 4 here. Okay, so let's build our squares back. And we have x minus 4 squared. And then we have plus y plus 2 squared. That was positive 2, and this was a negative 4. That's why we have it set up like this. And then it equals 16 and 4 is 20, and 20 minus 11 is 9. So, looks like this is starting to take shape. The x term is already okay. The y term is close, but not quite there. It's plus 2, and we need it to be minus. And then our radius is not quite there, but recognizing that that's just 3 squared is equal to 9, so we have 3 squared. And we have x minus 4. And then we have y minus a negative 2 squared. So the center of our circle here is at negative 4 and negative 2, and our radius is equal to 3. Whoops. It's actually positive 4. So we just put the coordinates over here at 4, negative 2, and we will draw a circle that passes through 3 above, 3 below, and then 3 over to the left. Just draw yourself a little circle. Okay. So hopefully that helps you out, and go ahead and stop the video and we'll do the last few in a minute.